friends. So, while we are having the linked list discussion, we are or we have already discussed about how to create a linked list with a given n number of nodes, and then n number of nodes we are taking out from the user. Similar way, we can determine the number of nodes in a linked list, already provided linked list, which is known as the length of linked list. Like in array also we have a particular size in which we store the elements. Similar way, in linked list also we can determine how many elements we can store in a linked list by determining the length of the linked list. Okay, so in this tutorial we are going to write a function, you can say a small function in C, so as to determine the number of nodes or the number of elements that are present in a given linked list. Okay, so before writing out the code or algorithm or anything, we need to first uh, think of the solution. How can we determine the length of the linked list? So I already told that there is a node, and the node structure is like we store here the data, and here we store the address pointing to the another node. Okay, so this is 200, address as 200. Then there is a data, and it contains the address of another node, which is 300. And then we have again here the data, and again we have the address as 400, which is the address of another node. And this 400 node at present at no address 400 is 40, let's say. And let's say here we stop our linked list, so we store the null. As I already told, the last node will contain null as the next pointer, because it is not pointing to any other node. And as this is the first node, so there is a head pointer, and this will have the address 100. Okay, so this will point to the first address. Now we need to know the length of the linked list. So we already know that the last node of the linked list there doesn't points to any further nodes, and the next pointer contains the null. So I think it is very easy to guess that if we keep on traversing the linked list until we are getting a null pointer in the next node, we can have a count type of thing, and we can increase its value up till we are getting the null pointer in the next of the node. And finally we can return this count as the length of the linked list, right? So let's program it, or let's write some code. Okay, so this is basically the concept here. Now, we already have the linked list, let's say. We just have to write a simple function or a simple functionality for determining the length of the linked list. We need to return the length of the linked list. So, int list length is our function. And of course, for a linked list, the very important thing, we need to provide the head. And what is this head? This is, of course, a pointer. And what type of pointer? This is a node pointer. Very important. Head contains the address, so it is a pointer. Okay. And what address, what uh, kind of address it contains? It contains the node address. Okay. So this is our function. Now, in this function, we will have a count as set as 0, integer count, which we will keep on incrementing as we traverse over the loop. I mean, as we traverse over the linked list. Okay. Now there could be some conditions we need to check, like if head equal to null. Now, if head is equal to null, then definitely the linked list is empty. So then and there we return the count as 0, because the length is 0. Okay. Else, it means that head is not null. That means the linked list contains some elements into it, maybe one or two or something. But we already have seen that we can't keep on incrementing the head. Head will always be pointing to the first node. So definitely we need to assign the head value to some pointer like q. Okay, so q will contain the head. Okay, so q equal to head. Now with this q we will traverse over the linked list, right? So while traversing, what condition will check? While next of q not equal to null. Okay, so while next of q not equal to null, we will keep on incrementing our count, or let's say we will be q equal to next of q, and then we will increment the count plus plus, that is count equal to count plus 1, and at last we'll return the count. Okay, now there are two things that I would like to discuss. This will return the count or the length of linked list. Okay, now you have seen these two statements. First, we'll be checking for the next not equal to null. Okay, so these two statements are quite confusing. Why I have not used count before this? So let's assume we did like this, and let's interchange these statements. Why I'm saying this is very important. Like, mhm, okay, count plus plus and q equal to next of q. Okay, now this logic we are going to check. Okay, so if there is linked list is empty, we are returning the count as 0. This works. Let's say for this example, we are checking the else logic. Okay, we have count value initially set to 0, right? Our head is 100. We assign q as head. Okay, now we are checking what? Q next of q not equal to null. So q of head is this. Next of q is this. It is not equal to null. We are incrementing count to 1, and we are setting q equal to next of q. Okay, like this here. You can check here in this logic. So first we are incrementing the count, and then we are setting it to the next of q. Okay, now q points to 200. We'll check, the condition will check q next of q not equal to null. Okay, so it is not equal to null, of course. So we are incrementing the count and we are setting it to 300. Correct? As provided by this logic, q equal to q next of q. Now we are pointing to this node. Okay, so now we again are checking next of q not equal to null. Of course, this is true. We are incrementing the count value and we are setting q to 400. Next of q, right? Now q points to this. Now we are checking while next of q is not equal to null. Okay, so next of q equal to null, so our condition will fail. So we won't be incrementing our count and we will be coming out of this while loop, and we will be returning count as 3. Okay, according to this logic. Now tell me, if this logic works here, we have 4 nodes but we are returning 3. Is it correct? Definitely not. So we may need to include or increment count as 1 afterwards, like count equal to return count plus 1 for the last node. So instead of that, we can remodify our logic, right? How we can remodify our logic? So we are checking the next of q. Let's not check this. Let's q point to the current node only. Okay. So we will be remodifying it as, let's not check the next. Why should we check the next? We will be pointing to the node itself. Okay. So just three lines we need to modify for this so that we don't get the wrong count. I mean the wrong number of elements in the list. What we'll do? We will check while q not equal to null. Okay. So q here points to 100, right? Q here points to 100, let's say. Now 100 is not null, of course. Then 100 is not null. Q points to this node. So definitely this is one node. So first thing we'll do, count plus plus. And now we will move this Q to next of Q, that is 200. We'll move it to here, right? And after moving, so for moving, we'll use Q equal to next of Q. Let's see this example also, because these things are important when we are doing the programming and when we need to think how this logic will work, okay, so that at the end of the game it doesn't fails up, right? Because these are very simple things, not hardcore fast rule of, but we are just examining how our program will work right now using an example. Okay, I could have shown by direct programming, but I think there also we need to debug to check how it is working. So okay, so now Q points to Q next again. So here Q is, we are checking for Q not equal to null, right here. So now Q points to 200 and 200 not equal to null. We are incrementing the count. So earlier we have incremented from 0 to 1. Now we have incrementing to 2, and then we are moving the count to this. Sorry, we are moving the Q to this. Again, we are checking Q not equal to null. Of course, Q is not equal to null. So we are incrementing the count to 3, and then we are doing Q equal to next of Q, that is, okay, that is, uh, this was 300, so this is 400. So now Q points to this. Now Q is, again we are checking Q not equal to null. Of course, 400 is not equal to null. We are incrementing the Q, and we are moving Q to this next of Q, that is null. Now Q points to null. So when Q points to null, we will definitely, this condition will fail and our 4 value will be returned. Okay. So this way we can return the correct value by just pointing Q to the current node. Okay. So this logic will work, right? So go for this logic and then we are returning the count. So it is a very simple logic, but we are not checking for Q next of Q. We are just checking for Q and pointing Q to each node. Okay. So this was one trick. So that's all about this. And next we'll see about insertion of new node at the beginning of the linked list and at the end of the linked list and at the middle of linked list. That is important. Okay. Thank you very much for watching.